All right, hello everybody. We've got a talk up now, welcome back from lunch. We've got a talk up now called Programming Lego Mindstorms Robots with Python. Stoyan used to be a clown in the circus and has found this very handy both in navigating the corporate life and in raising his kids. He applies the same agile slapstick approach to his coding, and Python helps him succeed fast and to succeed often. When not getting his dopamine fix with pip install, Stoyan can be found hacking Lego with his son or hanging off a trapeze with his daughter. Please welcome Stoyan.
Welcome to Programming Lego Mindstorms with Python. We're good with the microphone? My name is Stoyan and I'm a solution architect from InnoDev. This is a story about dreams come true. I've always wanted to have a robot. I'm not sure how the idea got planted into my head. Perhaps it was something to do with protecting the motherland. But I've been building robots out of cigarette boxes that I found on the street, toilet paper rolls, or yogurt containers. And when I was a bit older, I even joined the electronics club. Now, as you know, dreams fade away, life happens, and it wasn't until my son, Hugo, who is 7 years old now, started showing interest in Lego that I thought maybe I should resurrect this dream. So I did a bit of research in robotics toolkits, and I was looking for a few specific things. I wanted an all-in-one toolkit that would allow me to build straight out the box, that I shouldn't have to buy anything extra. I wanted something that is open-ended, so that I can keep building models, and I'm not limited to just 2 or 3. I wanted something with a good community and lots of resources. And finally, it had to be programmable in Python. So, at the beginning of the year, I made myself a somewhat expensive birthday present on behalf of the family. And that's how I ended up with the latest Lego Mindstorms EV3 model. So I had to act surprised when I unwrapped the box in front with the kids, and this is what we saw. It's a pretty good looking package. Inside of it are 601 parts. There's a brick controller, which is very important. This one here, it's the brain of the system. It runs Linux. There's motors, sensors, cables, Technic parts, and one set of instructions. It's amazing what you can do with 601 parts. It doesn't look like much, but the ingenuity is just fascinating of what people do. And if that's not enough for you, you can always go to some websites and get extra parts 3D printed for you that would fit nicely with your Technic parts. Or you can use your other Technic Lego models to combine them together and build something even bigger. Or you can have Technic to classic Lego connectors and just join everything that you always love playing with. Funnily enough, all these parts have names. And it's good to learn the names so that you can communicate better with your partners when you're building things together. This is a word cloud based on the count number of all the parts. And as you can see, the bush and the bio 9 are the most popular ones. They're the teeny tiny connectors that you can see connect all the parts over there. So next thing we did with my kids was to go to the Lego Mindstorms website and download a few extra models. They're available in PDF forms, and there's quite a few that are officially supported, and there's heaps of others that are contributed by the community. So as you can see, there's quite a variety, but we went with the EV3 Storm, which is the one on the top left-hand corner, which is a rolling, skating, talking, shooting robot that looks pretty cool, actually. The kids called it Betty. So once we built Betty, we had to give her the gift of life. And as we all know, we do this through programming. And the official way of programming Lego Mindstorms is to use either the Windows application or the iPad app, programmer app. And in both cases, it runs a dialect of LabVIEW, which is a graphical programming language, which you can you have a canvas and you have a toolbox and you drag from the toolbox onto the canvas, you connect them and configure them. And once you're ready, on the bottom right-hand corner, you connect to your EV3 brick, and you upload your program, and you're ready to go. These are some of the actions you have available to you in LabVIEW. You have control over your motors, over your speakers, lights, screen. You have logic flow controls for loops, iterators, and switches. You have control over all your sensors, of course. Then you have some more advanced stuff, such as variable assignment, mathematical constructs, and even more advanced stuff, such as file access, messaging, Bluetooth access. But, you know, why are we talking about LabVIEW in a Python conference? And good question. Because it's all those same features are available to a Python API. And number two, it's good to know what's available to you, just in case you have to program it in that. But even more importantly, very often you find yourself reverse engineering a program. And to do this, it's good to look at the original LabVIEW code and then work it out into Python. Now, in fact, the EV3 projects that we saw earlier, so all of this is contained in a project with an EV3 format extension. Those are actually just zip files. So you can actually unzip that to a directory somewhere, have a look at the contents, and you get out of it all the imagery, sounds, whatever's being used by the project, as well as you have access to an XML file which contains all the logic for the program, so this particular workflow. I have yet to work on on some kind of a converter from an XML to Python, but you know, it's coming. It's on the to-do list. Right. So how do we get started with Python then? Well, as I mentioned before, the brick over here runs Linux, and that's good news because the brick also comes with a little SD card slot over here. So that means that if we get our own SD card and we flash it with an EV3 dev image, which is a reverse engineered Debian instance that contains all the Python bindings for all the motors and the sensors, we can dual boot the system and run entirely in our own EV3 dev environment, Debian Linux, where we'll have Python running as well as some other languages. So the process for that is you get yourself a micro SD card, and it has to be under 32 gigs, otherwise it won't read it. Get yourself a wireless adapter, and I recommend some of those mini ones so it doesn't get in the way of your parts, the nano ones. You need to download the latest EV3 dev image file from the website, from the EV3 dev website. Then you have to flash it onto the SD card with a etcher, with a program like Etcher or equivalent. So once you do that, you take it out of the computer, you put it into a SD card slot, you press the button to power it up, and it boots into Debian Linux with EV3 dev available to you. So that runs a something called brick manager for the brick. So once you have the brick manager running, it means that you can actually configure your network. Using the buttons, you can navigate to your wireless connection, find the network you want, put in the password, and now you're online. Your EV3 is online. So once it's online, then it's just like any other server, any other Linux server that you're used to in AWS or whatever. You open up your SSH client. I use Bitwise. I find this very handy. It has a few more features over PuTTY or some of the other ones you may have heard of. Or you can use, I often also use Pythonista, which is an app on the iPad that does some pretty amazing things, and it has a SSH client as well. So you have your SSH client. You connect to your server, because it's a server now, and we're good to write code. Python is an obvious choice, but you also have lots of other languages to choose from. JavaScript, Java, Go, if you can be bothered. So how do we write Python scripts on EV3? How do we run them in the first place? So we write them, and then we run them by connecting via SSH, and just executing them like you normally would from the command line. The username and passwords are robot and maker. You're welcome to change them. It's not really a high security risk if you don't. Depends on what you're running, I guess. Option number 2 is you can use the Brickman. So you can use these buttons to navigate to your file, to the file system, find your file that you want, press the middle button, and the file will execute. There's a few gotchas though. It has to have Unix-style line endings, so Windows won't do. And there's a command that does a fix for it if you run into the problem. You have to make them executable. You have to make the file executable. And it's good to have the shebang line and as a first line in your Python script, so that when you run it from Debian, it knows which version of Python to execute. And officially, Python 3 is the only version that is supported. I've gotten some functions running on Python 2, but why bother? Just go with Python 3. Finally, you also have a remote Python call option. And that's what I use a combination of all of these 3 things. But when I'm exploring, I find the remote Python call server running on here allows me to run on Jupyter Notebook, as I am at the moment, and connect from the Jupyter Notebook using an RPyC client to the RPyC server. And now we have a remote connection so that the code I run from here can execute on here. And we'll see that in a minute. Obviously, we need to be able to stop the programs as well, not just running them. Control+C, use your go-to command. Pressing the back button and the backspace button over here. Press and hold, that usually does the job if Control+C doesn't work. In worst case, and it's happened to me, open it up, take the batteries out, and then there's no arguments. So here's a bit of a more detailed look of what we can control with Python. We have the brick, or the EV3 brick, in the middle. It has a screen, it has buttons, it has a few things, and it controls sensors and motors. So we'll cover all of this in detail. And I should also mention that there's the remote control, which is currently pretending to be Starship over here at the moment. So let's have a look at the brick then. The brick has a screen. It's a 178 by 128 monochrome screen. It's not huge, but it's good enough to give a bit of character to your creations. You can give it eyes, you can make it blink, things like that. You have buttons that you can navigate and do various other things with them. There's LEDs next to the buttons over here, left and right sets of LEDs. There is a speaker on this side, as you can see over there. On the other side of the brick, you have the SD card slot. You have the USB slot, and on the top and the bottom, you have ports for connecting to all the sensors. These are numbered 1 to 4, and are usually used for connecting the sensors. And the ones on top are numbered 8 to D, and they're used for connecting the motors. It's just a convention. You don't have to follow it, but it helps. Time to write some code. Here's an example of how I write my code. So, strictly speaking, you should be able to, if you're running straight on here, you can just go from ev3 dev import ev3, and you're good to go. However, I'm giving you a way where you can run both an PyC call as well as a ev3 dev call. So, line number. So we need to run our PyC, we need to define a host. We need to connect to the host, and then we need to load the ev3 module. So that makes an instance, gives us a connection from this computer to this ev3 module over here. And I usually give some kind of an indication for success that we're connected by doing a ev3 sound.beep. So working with sound. The speaker is not great, but it's good enough for what it is. We can set the volume of it. We can make it beep. And usually when you execute some kind of a sound command, it's good to do a .wait on it, because if you don't wait and then someone else tries to, another command tries to execute another sound command, then, and it's already in use, then there's a clash and there's a fight, and second one usually loses. So do a .wait, wait for the speaker to be released, and then you're good. You can play tones. You can reverse engineer frequencies into tones if you wanted to. But nowadays, as of the latest release of the EV3 Dev, you also have tones available to you to play through the play song command. So what we see over there is Beethoven's Symphony Number 5, da-da-da-dum, in two versions. It's a home-baked version and another version where you pass in the note and the duration, and you're good to go. If that's not good enough for you, you can take any MP3 file of yours that you like, use the PyDub, beautiful PyDub library, pip install PyDub, to convert your MP3 file to WAV, and then you can play it with a sound.play command, and make sure you wait, because songs are usually long. Finally, you can speak, and kids love that. So here we have an example of something that the computer can say, your EV3 can say. Right, so moving on to working with LEDs. As I mentioned, they're just the LEDs on the front over here, and you can control the left and the right, and you can give them different colors. So there's choices of red, green, amber, orange, and yellow. That's a good way of indicating giving some kind of a status, but also you can configure the delay on, delay off, so that you can actually do things like Morse code, for example, sending little signals or flashing to the tune of a music or something like that. And if you're not happy with it, just go ev3.leds.all-off, and it goes away. Now buttons. Buttons are pretty simple actually. You only have to instantiate one object from the button class, and then you define your event. You have to define some methods that will handle the events for the buttons. So in this case, we just, for a purpose of demonstration, we're defining a method for all of the buttons, and what it does is it's going to say what button is being pressed. So what we do then is we take the button class, and it has got event handlers. You assign the methods to the event handlers, and then we go into an infinite loop where we have to periodically process the buttons to see whether something has changed, and that triggers the event handlers to work. I've given you another example of how you can use the buttons, and that's using the check buttons function. And what we're doing here is the left and the right buttons are pressed simultaneously. That gives us a way out of the loop, because otherwise we'll be in there for a long time. As I mentioned, the screen is not very big, and before you start working with it, it's usually a good idea to run the change foreground virtual terminal command in Linux, so that you have a complete control over your screen and you're not fighting for it with your brick manager. So you run your sudo chvt number 6, and then you can import your Python imaging library. You instantiate a screen object, and then all the goodness of Python imaging library is available to you. You can draw text, you can load images, you can draw lines, rectangles, ellipses, things like that. Finally, release the screen with the chvt1. So sensors. Touch sense is pretty simple. You just press it, and then you're done. This is an example of how you can use the touch sensor. The color sensor is a little bit more interesting. It's almost the same, but it has 3 modes of operation. Color, where it detects 8 individual colors. Reflect mode, where it's good for following lines and things like that. There's an ambient light, and there's a RGB raw mode as well. So here's an example of how you can show something in front of it, show a color, and it will try to guess the color for you. The infrared sensor gets more interesting still. It gives you the ability to talk to this guy over here, which is the remote control, but also it checks the proximity, whether you're getting close to something. The remote control is one of the weaknesses of, well, that's what some people say, of the Lego Mindstorm. It has one blue button, one red button. They can go up and down, and you have 4 different channels. So the little button, the red button over there, can change the channels. So you can have 4 times 4, 16 different operations which you can perform at one time. This button over here is the beacon button. So you can, when you activate it, this can follow this. Here's an example of how you can use it. You can run it at your leisure a little bit later. Now, I should mention, this is an executable Jupyter notebook. Is available on GitHub, so you're welcome to have it. The large motors. Okay, so large motors, this is where it gets complicated. And the reason for that is that there's lots and lots of functions available for your motors. Running forward, turning to a specific degree. The things to remember is that one tacho count is 1 degree. So when we try to control the motors, we have to think in terms of degrees and revolutions. So 360 degrees is 1 revolution of the motor, which means that if you want it to turn once at the speed of 1 revolution a second, we have to specify a speed of 360. If we want it to go backwards, we go a minus 360. And it's usually a good idea to wait while something is running. So in this case, we're going forward, we're going back, then we're stopping, and then we're going backwards for 5 seconds to reverse our direction. The medium motor is pretty much the same operations. It has got less power, but it has got more control and precision. Right, so putting it all together, EV3D4, live demo. As I said, this is a Jupyter notebook, so I can execute code from here, and because I'm running a RPyC server here, things should be able to talk together, unless something's timed out. All right, so here it goes. We're going to import the EV3 libraries and connect. This was a beep. It's a good sign. Moving on to the next. Here we have a move function. In the previous slide, we defined a thread signal, which will allow us to have a couple of threads communicating between each other. So this move function is going to handle moving forward. So we're going to go execute. Oh, I need it to be in it. Okay, execute. We have a fill function. The fill function, what it does is looks for proximity. And when it happens, it sends a signal to the move function to do something else. So let's click in here, execute. Okay, so it's all running in memory. Now we are about to trigger it all. So what we have here is we are instantiating the 2 threads, we're starting them, and we're going to an infinite loop and waiting for the threads to finish. That's a common paradigm. So it's moving. So if I close, okay. So it's asking where should I go next until I press the touch button. So the poor thing is wondering, so.
Where should I go next?
It's, as I said, the speak is not great, but we'll put it out of its misery. I think it said farewell and goodbye, if you could hear it. So that's the end of the live demo. Thanks. And now that we know what Lego Mindstorms are, now that we know how we can program them, where do we go to next? I've given you a list of resources, which are very thorough and a very good start. The GitHub repository where I've put the source code is on there as well. And there's quite a few books available which I highly recommend that they're really excellent, especially in constructing, in helping you understand how to construct the motors and how they drive together. So with that, thanks for your attention, and if you have any questions, I think we have a couple of minutes.
Thank you very much. Thank you very much. That was great. Has anyone got questions? Hands?
I have a child as well, so it'll be a good toy to share. And I was just wondering what sort of CPU it has. I am not quite familiar with this.
Actually, I don't know the details. It's not a huge amount.
Yeah.
But if that's not enough for you, a good idea is to actually run all your computations on your laptop and then connect remotely via RPC and execute just the control functions. So, for example, the record holding Rubik's Cube solver was doing all its computation offline, and they're just sending the instructions.
The mechanical instructions to the controller. Okay.
Yep.
Cool.
Anyone else? Questions?
And one more on that note, if that's not enough for you, you can actually get a BrickPi, which is a Raspberry Pi which can interface with the Lego Mindstorms as well. And the same EV3 dev operating system can work on it. So all your code that you've already written, you can move straight to it.
Hey, how long did it take for you to build that robot? Including the coding and the whole putting the parts together?
Yeah, so instructions are usually between 50 and 300 steps. So it takes my son about 6 to 8 hours to build a model, and he's pretty good at this, but he's 7. So expect your mileage to vary, but it's it's fun. Time flies. It's good fun, and when you're exploring, it's good to think about how it was built in the first place, and when you pull it apart, good to think to reverse engineer how it was built as well, so that you can modify it and use it later. In terms of the coding, I've spent hours and hours just playing around, getting used to the API. But I think the Python, the Jupyter notebook that I've provided you is going to give you a heads up, much like I wish I had that when I started.
Thank you.
Anyone?
Just curious, after you installed that, do you still have access to the stock application and using the graphical coding stuff?
You just have to remove the SD card out, and then it's back to normal.
Nice.
So it's a dual boot.
I'm going to actually interject a question here, because I've got the microphone again. What electrically are the little ports? Are they like 5-volt motor drivers directly, or are they driving a smarter motor like an SPI thing?
I'm a CS major. Sorry, I can't answer that.
It's okay, cool, thank you. Anyone else? We've got like another 2 minutes, I think. Hi. Do you want a microphone?
Yeah.
Yeah.
How can the robot fly? Can you make it fly?
How can I make it fly? Yes. Yes. See me after.
Cool. Anyone else? No? All right. Well, thank you very, very much. That was great. Thanks.